Hello there, Mr. Sutton here, bringing you the AB Calculus 515 homework solutions on integration by substitution with definite integrals. For number 1, we're trying to find the definite integral from 0 to 1/2 of this crazy rational radical expression. So looking at this thing, I do notice that I've got an x squared and its derivative, 2x, in the same problem. So integration by substitution seems like a good shot on this one. I'm going to let u equal 1 minus x squared. I'm not going to mess around with that square root just yet. Derivative of that, we're going to have du equals negative 2x dx. And then I'll divide by negative 2x to get dx by itself. And I'm also going to replace these x values up here with u values. If x is 0, that means u is going to be 1 minus 0 squared, or just 1. And if x is 1/2, then we're going to have 1 minus 1/2 squared, which will be 3/4. So now substituting everything back in, I'm going to have the integral from 1 to 3/4 of 2x over square root of u times du over negative 2x. All right, let's simplify this a little bit. These 2x's cancel. I still have a negative 1, so I can rewrite this as negative integral from 1 to 3/4 of, let's see, I'll make this u to the negative 1/2, just to make my next step a little bit easier. And now, using my reverse power rule, I'm going to bump that up to a 1/2 and divide by 1/2. So multiplying by 2, my antiderivative then is negative 2u to the 1/2 from 1 to 3/4. Now I have to plug both of these in. These are u values. Since I've already got this expressed in terms of u, I can just plug in directly. I don't have to substitute this 1 minus x squared business back in here. So I'm going to have negative 2 times the square root of 3/4. And then minus, but I'm subtracting, so plus 2 times the square root of 1. And simplifying this a little bit further, let's see, square root of 3/4, that's radical 3 over 2. 2's cancel, so that's just negative radical 3 plus 2. And looking up here, oh, I've got that answer choice, choice E. It's written backwards, but it is the same stuff. For number 2, trying to find the integral from 2 to 3 of this expression. So there's no way to really factor this or use any other kind of techniques, but I do notice that the derivative of x squared plus 1 has an x in it. So integration by substitution might work here. Let's let u equal x squared plus 1. So then du would be 2x dx. Dividing by 2x to get dx by itself, I've got du over 2x. And I don't really like these being x values for my limits, so let's change those to u values. If x is 2, then u is going to be 2 squared plus 1, so 5. And if x is 3, we're going to have 3 squared plus 1, so 10 for the u value. Plugging all this back in, I've got x over u times du over 2x, and now my limit's going from, or my integral's going from negative 5 to positive, or positive 5 to positive 10. No negatives at all here. All right, canceling out those x's, I've got 1/2 times, let's see, this will be u to the negative 1 if I want to write it that way, or I could just write 1/2 times 1 over u. Either way, 1 over u, antiderivative there, that's going to be ln of absolute value of u, 1/2 times that. And I'm evaluating that from 5 to 10. So I've got 1/2 ln of 10 minus 1/2 ln of 5. No need for the absolute value, but you can leave it in if you really wanted to. And looking at the answer choices, I don't see that anywhere. Well, that means we need to simplify using some log rules. I could factor out a 1/2, and inside I would have ln of 10 minus ln of 5. But now when we're subtracting logs, we're dividing the stuff inside. So I can rewrite this as 1/2 times ln of 10 over 5. And then if I reduce that to ln of 2, I finally get something that's in one of my answer choices, choice B. For number 3, we're trying to integrate from 0 to pi over 2 this rational radical trigonometric expression. Whole lot of things going on here. Since I noticed that I have a function and its derivative in the same integrand, I'm going to try integration by substitution on this. Let's let u equal 1 plus sine of theta. I'm not going to mess around with the square root, but I can replace the stuff inside of it at least. So then du is going to be cosine of theta d theta. Dividing by cosine, we have d theta all by itself with du over cosine of theta. Next, let's swap out these theta values in the limits of integration for u values. If theta is 0, then that means u is going to be 1 plus sine of 0, or just 1. And then if theta is pi over 2, well, then we've got 1 plus pi over 2, which is 1 plus 1, or 2 for u. Subbing all those things in now, we've got the integral from 1 to 2 of cosine of theta over square root of u times du over cosine of theta. Next, these cosines can cancel out. And I'm going to rewrite this square root of u down here as u to the negative 1/2, just to make it a little easier to integrate. Now let's use our reverse power rule on this thing. So we've got, this gets bumped up to a 1/2 power. Dividing by that, we're actually multiplying by 2. So I've got 2 times u to the 1/2, all from 1 to 2. And then this is really just square root, and these are u values now, so I can plug them in directly. So I've got 2 radical 2 minus 2 times radical 1, which is just 2 radical 2 minus 2, which is, let's see here, answer choice, oh, none of them. Well, they were kind of tricksy on this one. If you factor a 2 out of these, you've got 2 parentheses radical 2 minus 1, so that would be answer choice D. For number 4, we're trying to, for x greater than 0, take the antiderivative of 1 over x times the definite integral from 1 to x of du over u. So first step on this one is don't panic. It's going to be okay. Second thing to notice that they said for x greater than 0. Well, we wouldn't really need to specify that if we had just these x's in the denominator here. There's probably going to be an ln involved if we're specifying that x has to be greater than 0. So let's get to the bottom of this. We've got a 1 over x in here, and we also have a definite integral from 1 to x of du over u. Let's start with this definite integral. So I know that the antiderivative of 1 over u is just going to be ln absolute value of u. If I plug x and 1 in for that and subtract, I have ln of x minus ln of 1. Okay, well, ln of 1 is just 0, so we can simplify this a little bit more. And now we're taking the definite integral of something that has nothing but x's. This is a good thing. And I have 1 over x and ln of x. Now, I notice here that, the derivative of ln of x is 1 over x, right? So I've got an x in the derivative of this expression. How about I try swapping out ln of x for u and going from there? So then du would be 1 over x. And getting dx by itself, that would be x du. Okay, let's swap back in here. So I'm going to replace this ln of x with u, and dx is really x du. These x's are going to cancel, so this is just u. And what is the antiderivative of u? Using our power rule, reverse power rule, that's going to be u to the second divided by 2 plus c. And let's see, that's none of the answer choices because we have to substitute ln of x back in. So this then will be 1/2 ln of x, the quantity squared, plus c, like so. And that is going to be answer choice E. For number 5, using the substitution u equals 2x plus 1, this integral is equivalent to which of the following? So the nice thing about this problem is they're pretty much telling you how to start it. We have to let u equal 2x plus 1. And then we'll just follow our normal steps for u substitution of definite integrals. So let's start with the derivative. That'll be du equals 2 dx. Dividing by 2 to get dx by itself, we have du over 2. Next, I have to get some u values instead of the x values they started me with. So if x equals 0, then u is going to be 2 times 0 plus 1, or just 1. And if x equals 2, then u is going to be 2 times 2 plus 1, which is 5. Making all my substitutions now, I've got the integral from 1 to 5 of the square root of u times du over 2. Okay, moving a little bit further here. Let's see, I've almost got an answer choice matched. If I move this 2 out in front as a 1/2, now I can match this with the answer choice. Let's see, that's going to be choice C. For number 6, using the substitution u equals sine of 2x, this craziness is equivalent to which of the following? Well, they're telling us how to start the problem. Plug in sine of 2x for u. So let's let u equal that then. And then we need the derivative, so that'll be du equals, this will be 2 cosine of 2x if we use our chain rule in there. Okay, let's divide by 2 cosine of 2x to get dx by itself. And before we plug this back in, let's also swap out these x values here for u values. So if x equals pi over 6, what does u equal? Well, that would mean that we're taking the sine of 2 pi over 6, which is really the sine of pi over 3. Sine of 60 comes out to radical 3 over 2. And then if if x equals pi over 2, multiplying that by 2 in here, that's really just taking the sine of pi, which we know to be 0. So plugging it all back in, we have the integral from 0 to radical 3 over 2 of, well, let's see, we're swapping out sine of 2x for u, so this is going to be u to the 5th. And then we still have a cosine of 2x initially, and we have a dx, or rather a du, over 2 cosine of 2x. Next step, the cosine of 2x's are going to cancel, and we've got a 1/2 that we can bring out in front. And let's take a look to see if I have any of those answer choices looking at me. Let's see here. It looks like choice D matches this, so we're done. On number 7, using the substitution u equals square root of x, what is this equivalent to? So this is another one of those problems where you have to replace stuff with u values. Let's start by letting u equal square root of x. I mean, we know we have to substitute u in here, but things might shake out a little bit differently depending on what this derivative comes out to. So if I take my derivative, I've got du equals, and this is going to be 1/2 x to the negative 1/2 dx. Or if we simplify that, you could make this 2 over the square root of x, because you have x to the negative 1/2 is your square root in the denominator. Multiplying by both sides to get dx alone, we've got 2 radical x du equals dx. Next, we have to swap out the x values in the original with u values. So if x equals 1, then u equals the square root of 1, which is just 1. And if x equals 4, u is going to be the square root of 4, which is 2. So we have the integral from 1 to 2 of, we're now going to have e to the u over u. Well, actually, this is where it gets a little bit tricky. So I'm actually going to leave this square root of x alone down here. And you'll see why I do this in a minute. But going back here, we've got integral from 1 to 2 of e to the u over radical x times 2 radical x du. And now this is why I left this square root alone, where I would normally just replace it with u, because this radical x and this radical x need to cancel out. So canceling those, I've got 2 that I can pull outside here, times the integral from 1 to 2 of e to the u. And let's see here, that's going to be choice C. For number 8, f is a function such that integral from 6 to 12 of f of 2x of dx equals 10. So which of the following is true? This is kind of a tricky one, but the key on this one is looking at all these answer choices. Notice that they all have t in them instead of x. Well, there must be some substitution then involving a t. So if we have f of 2x here and f of t here, then most likely what happened is they let t equal 2x. So let's use a substitution. I guess it's t substitution on this one instead of u substitution. And let's see if we can unravel this thing. Derivative here, we'll have dt equals 2 dx. Dividing by 2 to get dx alone, we've got dt over 2. And I'm going to swap out these. These are x values. I want t values. So if x is 6, then t is going to be 2 times that, which is 12. And if x is 12, t is going to be twice that, 24. So then I've got the integral from 6 to 12 of, this will be f of t, and instead of dx, we've got a dt over 2. That all equals 10. So I can pull this 2 out as a 1/2. So I've got 1/2 of this equals 10. But now look at the answer choices. There's no 1/2 kicking around here. So what must have happened, to get rid of this 1/2, we have to multiply both sides by 2. That'll give me this integral equaling 20. And that is going to be answer choice B. For number 9, if the substitution u equals x over 2 is made, this crazy integral equals which of the following? Well, let's start by doing what they said. Substitute u for x over 2. So when you do this, you're going to need to take the derivative of both sides. So that'll be du equals, this will be dx over 2. And then if I multiply to get dx alone, I've got 2 du. Next, I need to get some u values. So that's going to be, let's see, if x is 2, then u is going to be 2 over 2, or 1. And if x is 4, we're dividing that by 2 to get u. So that's going to be 2. A lot of rhyming going on here. And if I substitute this stuff back in, I'm going to have integral from 1 to 2 of 1 minus u squared. And instead of dx, I've got 2 du. But we run into a problem here. There's nothing that's going to cancel out this x. So I'm going to have to take one little extra tricky step. I'm going to have to replace this x with something that has u's in it. So I'm going to multiply both sides of this substitution by 2 and get x equals 2u. And now I can replace this x with a 2u. I could also do that up here, but I'm not going to bother since I've already got something better I can replace that with. So we've got then integral from 1 to 2, 1 minus u squared, and now we have 2u down here. This 2 and this 2 are going to cancel out. And let's see, do I have that in one of my answer choices? We've got 1 to 2, so it's down to a, d, and c, and I'm looking for 1 minus u squared over u. Yep, that's going to be choice A. For number 10, I'm trying to integrate from 0 to 1, x cubed times e to the x to the 4th. Since I see an inner function and its derivative in the same problem, I'm going to try integration by substitution. So let's let u equal x to the 4th for this one. So then du would be 4x to the 3rd dx. Dividing by 4x cubed, we've got du over 4x cubed equaling dx. And let's get some u values too, because right now we've just got x values. So if x equals 0, then u is going to also equal 0, 0 to the 4th. And if x equals 1, u will also equal 1. Hey, 0 and 1 are fun to work with, right? So we've got the integral from 0 to 1 of x cubed times e to the u times du over 4x cubed. And then I can cancel out these x cubed, so I have 1/4 e to the u, whose antiderivative is just going to be 1/4 e to the u. So I need to integrate that now from 0 to 1, and since these are now u values, I made sure that conversion was complete. I can just plug these in directly without replacing with x to the 4th here. So I've got 1/4 and then e to the 1 times, or rather minus e to the 0. This is just going to be 1/4 times e minus 1, and it looks like that's going to be answer choice A.